Hey everybody, today this will be the last topic for this week. So we're going to look at something called trig identities. So these are probably going to be probably like the least enjoyable experience maybe in the course. Now, I mean, the sad part is that normally we would get to experience the sadness together and this frustration. But now you get to do it by yourselves. But again, I am here remotely, and if after going through today's lesson and you trying the homework, if you're still stuck or if you got problems, you don't seem to get a handle of this, let me know. I may, given that this stuff is kind of complicated, if if the people want it, then we can have like a little Google Meet where we can do identities, or I can go over your questions or whatnot. But again, just like we've been doing all along, if you got any questions, then just ask me via email or on the classroom. Okay. So what an identity is kind of like it's like a rule that is true for all things in trigonometry. So I kind of use an example, like like when you study physics, like gravity, right? Like, gravity exists, there's certain fundamental things that happen with gravity and how it affects certain things that you would study in physics. And these things are always true, right? Here, a trig identity is going to be something that is always true in trigonometry, okay? So what we'll do is I'll kind of develop the first two that we cover, and then we'll just use them. So like you don't really have to worry about what I'm doing right now. I mean, it's more just to show you like why this is working, okay? Or like, where this comes from. So anyways, here, if you look at our picture here, I got my initial arm chilling on the x-axis. It swings. So this is my terminal arm of a swing of theta, x, y, and r. Okay, and in this quadrant, right, my ratios are sine theta is y over r, cos theta is x over r, tan theta is y over x. Okay, so hopefully by now none of this is weird or doesn't make any sense. So generally, what mathematicians came up with, so like the first kind of thing is they looked at this stuff and said, what if we do something like this? This like sine theta divided by cos of theta. Okay. And again, the reason that they, like you have mathematical intuition, you're like, like I want to see what's going on. So again, like I could write this as sine theta over cos, right? Or you could write it just like this, whatever, it doesn't matter, okay? So like what is sine theta? Well, if I go up to my picture here, right, like I have sine theta is y over r. And what's cos of theta? Well, it's just x over r. So I'm going to plug in those values here, right? So I have y over r divided by x over r, okay? And then I have, if I remember how I deal with dividing fractions, right, this becomes that, right, y over r times r over x, and then the r's kind of cancel, and then I'm left with y over x. Now again, if you may be like, yeah, whatever, man, who cares? I don't care. Well, y over x, if I look, check it out, right? Y over x is actually 10 theta. Okay. Okay, so that means that tan of theta I can write as sine theta over cos of theta. So this is my first identity. Okay, we call this the quotient identity. Okay? And again, so if you don't believe, if you're like, yo, this guy's all full of it, doesn't like it's not true, right? That just means like tan of 45 degrees is going to equal whatever sine of 45 is over cos of 45. Okay, input any theta, and again, I mean, you got lots of time. If you're stuck at home, as we all are, not doing anything, go ahead, start from 0 to 360, plug in every angle, and this will be true forever. Okay. So the next one, mathematicians were sitting there and just being like, what about something like this? Like, why don't we take sine theta and square it, and then take cos of theta and square it, and see what that equals? Okay. So again, if I go back, if I remember like my ratios here, right? Sine y over r, cos x over r. So then if I go here, so I have y over r squared plus x over r squared, right? So then you're like, okay, that's cool. I have two fractions. They're and I'm adding them, which may freak you out because you're like, oh, I got to find a common denominator. But the good news is these denominators are already common, right? So this just equals y squared plus x squared over r squared, okay? So now, right now, to the untrained eye, you'd be like, yo, like this is complicated, right? Like I have this y squared plus x squared over r squared. Like, what, obviously there's a pattern here. What is it? Well, if I go back here, look, like what is r squared? Well, r squared is just, right, using the Pythagorean theorem, this side squared is this side squared plus this side squared. So really what, like this part, right, this is equal to r squared. So what I have is I really have r squared over r squared, and that just equals 1. All right. So that means, well, what does sine theta or sine squared theta plus cos squared theta equal? Well, this equals 1. So this is my second identity, okay? Right? Now, just a thing, like normally we don't write it like with this bracket squared because it just looks weird. So when I have a sine theta or cos theta squared, I usually write like this. Like I write the sin part, and then I write the squared between the sin and the theta. So sine squared theta plus cos squared theta equals 1, okay? And this we call the Pythagorean identity. Okay? So I have the quotient identity and the Pythagorean identity. Now this one, there's a little bit more to it because here what I can do, this one has a few different useful versions. All right. So for example, I could write it like this: sine squared theta equals 1 minus cos squared theta. Okay. But then this here is a difference of squares, so I can write this like this. Okay. or if I want to, I can isolate this, right? Cos squared theta is 1 minus sine squared theta. This is also a difference of squares, which I could write like this. Again, like here, we just have some algebra here. Like, so like notice when I say difference of squares, that's taking you back to thinking about quadratics. And the reason that these questions are generally painful is because these trig identities deal with all the algebraic rules that you have ever experienced in your mathematical life. So like BEDMAS, distributive property, adding fractions properly, multiplying, dividing fractions, factoring, all that kind of stuff come into play in these questions. So generally, not only do you got to remember these identities, but you got to make sure your algebra skills are top notch. Okay. So anyways, so in terms of, just in summary, okay. Right. So we have we have the identity here. Tan theta is sine over cos, right? That's an identity, right? And then I have this one, right? The Pythagorean identity. And then we actually, the other ones, like remember when we did reciprocal ratios, right? So like we did secant of theta, well, that's 1 over cos. And then we had cosecant of theta, well, that's 1 over sine. And then we had cotangent of theta, well, that is 1 over tan, okay? So I have the first one, right, the quotient. The second one here, Pythagorean. And then these ones here, I'll call, number 3. These are just the reciprocal. So we got to remember all of these, and then we're going to use them to to prove trig identities. Okay. So let's try one. So here is an identity. Okay. So notice the nature of the question. Here you're given, essentially it's an equation. You got this, like here, right? I have this left side equals the right side. Okay. Now you're not solving. Right here, we're not solving for theta. Okay, we are proving that this side equals this side. Okay, so essentially what we're going to do is we're going to treat each side separately and show through identities that we did on the previous slides that these two things are in fact true. So like this is true. Tan squared theta plus 1 does equal secant squared theta. Now we just have to prove it using identities. Okay, so first rule here, right, I'm going to say, okay, left side equals tan squared theta plus 1, okay? And I'm only going to use the left side. I'm not going to bring the secant squared theta across. I'm not isolating it for anything. I have the left-hand side here, and I'm stuck with it. I need to change it. Now, what can I change? Well, like here, right, like tan is an identity, right? If we look, like what's tan? Tan is, oops, where'd I go? Oh, did I delete that page? Anyways, tan is sine over cos. So I'm going to change tangent to sine over cos. So notice this is tan squared. So I'm going to write like this: sine theta over cos theta squared plus 1. Okay, everybody cool with that for now? So now I say, okay, well, what do I do next? Well, let's just keep this squared, right? So I'm gonna write this as sine squared theta over cos squared theta plus 1. Now, what can I do, right? So here's where you have to think about it algebraically. Like if we look at our algebraic toolkit, so what kind? Well, like here I have like a fraction plus a whole number. So what I can do is I can find a common denominator so that I have only one term, because the right side here, secant squared theta, is only one term. Okay, so the sine. So this stays the same, right? Sine squared theta over cos squared theta plus, but what's my common denominator going to be? Well, it's going to be cos squared. So this is I'm just going to write it as cos squared theta plus cos squared theta. Because again, this is 1, right? 1 over 1. And if I want to multiply this by cos squared theta, multiply this by cos squared theta to get my common denominator. Okay? And then, well, I can write the top together. So sine squared theta plus cos squared theta. And that is all over cos squared theta. And then now you say, well, okay, if you remember, right, like this, the top part is the Pythagorean identity. So what does sine squared theta plus cos squared theta equal? Did someone say 1? Yeah, sure, of course. That equals 1. So 1 over cos squared theta. And then what is 1 over cos squared theta? Well, it's actually secant. It's secant squared theta. So see how we've started with the left side? We've changed, like, you know, if I highlight the areas where we changed stuff, right? Where did I change? I use an identity right here, right? And then where else did I use an identity? Right here, okay? What did I do here? Right, well, this was just using the fact that I have to find a common denominator. So it's just like general mathematical algebra, right? So I've proven, right, because this is the right side, right? So generally here we say, therefore, the left side equals the right side. And we're good, all right? So let's just try some more. And again, we'll do a couple, and then you just got to promise me that you actually try some, because I mean, if you don't practice these, obviously, no joke, you're going to suck at them. But for those of you who obviously are planning on taking more math, like you're going to be doing these types of things in grade 12. And guess what? There's way more identities than the ones that we just talked about in grade 11. Okay. So same thing here. So let's deal with this one. So again, one of the choices you got to make is like which side is better to start with. Okay, you have to kind of triage the situation. So like, you know, you look, and the more you practice, the more you'll realize that you'll be able to figure it out. But like, so I'm going to say that like the right-hand side looks more messed up because I have like sine, coses, and tans, okay? So I'm going to start with the right side. And then I have to, through identities, show that this is going to equal 1 minus cos squared. Okay, so again, when I do these, I'm like, okay, I got, like, I know I see tan. Tan is an identity, so I'm going to change this. Sine times cos, I'm just going to leave. Okay, so I have sine theta, cos theta times, well, what is tan? Tan is sine theta over cos theta. And then now, well, this is all being multiplied together. So it's sine times sine over cos. So like the coses actually go away. So then I'm going to have sine squared theta, because sine times sine is sine squared. And then, well, if I look at the left side, what's the left side? The left side is 1 minus cos squared theta. But if you remember from the Pythagorean identity, right, where I had sine squared theta plus cos squared theta equals 1. And then I said, well, sine squared theta is just 1 minus cos squared theta. So this equals just sine squared theta. Those two are the same, so therefore left side equals the right side, and I am super stoked. Okay? So again, these obviously, like, these are weirder questions because you're using these identities for the first time. But again, you just gotta like have these identities kind of, as you're making your notes, you have them. Like, you don't have to memorize them. You can see them, and then just do your best with manipulating the equations. Okay, so again, here, let's see, I have left side equals right side. They look both similar. Like, there's not one that's more or worse than the other. So like here, I'm just gonna take the left side just because. Okay, so I have sine theta over 1 plus cos theta. So here, right now, like, I guess the problem is there is no identity to use. Okay? So like, if this were squared, then that would be great, because I could use an identity, but it's not. So here's where we use a trick that we have used prior to COVID-19 when we were in normal school. Remember when we would multiply by 1? And multiplying by 1 doesn't technically change the value or the weight of the equation or the expression. And it's a mathematical trick that we can use. So I'm going to do that. So if you remember, here, remember when we had something like this, I had 1 over, and then I had like 1 minus root 3, and we had to multiply by the conjugate, right? The conjugate. This was, I think, I think this is like the last week of normal classes when we talked about this. I think. I could be wrong. But yeah, so here, what we're going to do is we're going to multiply by the conjugate. So now, which conjugate? Well, the conjugate here is, well, what's the conjugate of 1 plus cos? It's going to be 1 minus cos theta over 1 minus cos theta, okay? Now, again, why are we doing this? Well, if you remember what we did way back then, right? So what I'm going to have sine theta times this, and then I'm going to have like 1 plus cos theta, 1 minus cos theta. So you may be looking at this and saying, hey, like, this is way more complicated, right? Okay, and I'm like, well, okay, I guess, but the denominator here, right? Like, this thing here is going to be a difference of squares, right? So what I'm going to get is this. I'm going to get, the top I'm going to leave, right? I have sine theta, 1 minus cos theta, all over, if I expand this, well, what's 1 times 1? 1, and then 1 times minus cos, and then cos times 1 is, like, they cancel each other out. So now I'm going to be left with minus cos squared theta. Right, remember, if I had x plus y times x minus y, that would just equal x squared plus xy minus xy minus y squared. The stuff in the middle here go away, and I'll just be left with x squared minus y squared. So that's what I have here. And then you're like, well, okay, where's my identity? Now I get to actually use an identity, right? This, if you remember from the previous question, is equal to sine squared. So I'm going to have sine theta, 1 minus cos theta, all over, and the bottom equals sine squared theta. And then what can I do? Well, that means that that theta goes away, and then I'm going to be left with 1 sine theta underneath. So I'm going to have 1 minus cos theta over sine of theta. And if I go all the way up to the other side, that is what I'm supposed to prove that it is. Man, I'm so stoked. It's so good. Okay. So this equals the right side, right? Therefore, left side equals the right side. And that is amazing. Okay. So yeah, so again, definitely probably the hardest part of the course. I know it's weird. And it's definitely something that is completely new. Okay, but you need to make sure that you try the questions. Okay, I'm not like if you want to figure out how to do this, you got to try. If you don't and you're going to give up, then you're just not going to be able to do it. I understand that stakes may not seem too high given our current situation, but you're going to have to deal with this next year as well. Okay, so you need to promise that you try. It's going to suck. Some of the questions you may find weird and you struggle through them, but there is value in suffering through these questions. You will learn how to do them and you'll become a better person. All right. So on that note, like I said, try to look at the homework and then shoot me a message if you got any problems. And hopefully it's not as bad as I have made it out to be. Okay. Take care. See you guys later.